All right, so in this video, we are going to be talking about using exponent properties to simplify expressions. So this is technically a review of what you learned in 8th grade. The properties may seem similar, but we're going to be going over it and practicing them because they can be kind of tricky. So just a review of the vocabulary with exponent properties. This part is called the base. This part is called the exponent, and the thing as a whole is called a power. So just a reminder, when you have x to the 5th power, it represents repeated multiplication. So x to the 5th is really x times x times x times x times x. Just a shorter way of writing it is as 1 power, x to the 5th. So these are going to be in Google Classroom, so you definitely don't need to copy this down, but these are all numbers that you should know, you should recognize, and you should be able to come up with quickly. It's going to help you with this unit and with the next thing that we do after this unit. So it's just really helpful to have these numbers just ready to go at the top of your head. So they'll be in Google Classroom for you, but it's kind of expected that you'll just start to memorize them and get used to knowing them. Okay, so let's look at the product property first. So here we have x to the 5th times x to the 3rd. So we could expand it out to write x to the 5th, as we saw before, x times itself 5 times, times x to the 3rd, which is x times itself 3 times. So in total, x is being multiplied together 8 times, so we can shorten it to be x to the 8th power. So in words, we can say when multiplying like bases, add the exponents. So just an example of what not to do. If we have y to the 4th times x to the 3rd, we cannot write this as xy to the 7th because y and x are not like bases. So don't do this. This is only when the bases are the same. So let's look at a couple of examples. So we've already kind of seen this when we were doing polynomials. What I like to say is I like to say multiply your coefficients, add your exponents. So my coefficients are 5 and 7. So since this is a multiplication problem, I'm literally going to multiply 5 times 7 to get 35. Then x to the 6th is being multiplied by x to the 1st. Don't forget your invisible 1. So 6 plus 1 is 7. So I'm adding my exponents. Y to the 8th and y to the 10th add to make y to the 18th. And that's going to be our final answer. As long as I have one of each variable, my answer is complete. So for this one, my coefficients are technically 1 and 1. So I would multiply them, but 1 times 1 is just 1. A to the 10th times a to the 4th. I add the exponents to get a to the 14th. Same with the b's. B to the 5th and b to the 6th. Add to make b to the 11th. So this problem should be on another slide. I'm just going to cross that out for a quick minute. I think it just bumped up to this one by accident. So those are our product property examples. Our power property is when we have a power raised to another power. So in this problem, y to the 4th is being raised to the 5th. So I could expand it out to be y to the 4th times 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 y to the 4th, 5 times in total. If I count up the y's, this is y times itself 4 times. 4 more times make 8, 12, 16, and 20. So y to the 4th raised to the 5th power can be simplified to 20. So if you noticed, all I did was multiply 4 times 5. So this rule says when raising a power to a power, you're going to multiply the exponents. So in this case, I have to make sure this 2 goes to every base in the problem. That includes the 4. So I have to square 4. I have to give it to the a to the third, but my rule is to multiply these two numbers. So that becomes a to the 6. 6 times 2 gives me b to the 12th. And so this is why I was saying memorizing those powers is really helpful, because 4 to the second power, 4 times 4 is 16. So my final answer for this one is 16, a to the 6th, b to the 12th. For this next one, I have to give the power of 3 to the 4 and to the x cubed. So I get 4 cubed, and then 3 times 3 makes 9. And then again, having 4 to the third memorized as being 64 makes this problem a lot quicker. 64 x to the 9th. And so the problem on the other page that I crossed out was x plus 3 raised to the 5th, all raised to the 6th. So I do have a power to a power here. So 6 needs to go to the 5. That's going to multiply to give me 30. That's where I stop. Do not distribute or give the power to addition or subtraction. You are not allowed to do that. You only can give it to multiplication or division like we were doing up here. So this is where we stop. We don't go any further. So don't go any further. Do not write x to the 30th plus 3 to the 30th. This is one of the things that makes math teachers the saddest. So don't do that. All right, for the quotient property, if I were to expand this out, I would get x to the 5th, which we've seen as x times itself 5 times, divided by x times itself twice. And we know that a number divided by itself make 1. So we can just cross that out. X divided by x makes 1, so that's gone. So I'm left with 3 x's being multiplied together, which is x to the third power. So what you notice is 5 minus 2 makes 3. So when dividing like bases, you should subtract the exponents. So for this one, it would be helpful if I had it written as a quotient like I do here. So since this is a fraction, I'm just going to turn this into a fraction, and I'm going to multiply like I would two fractions straight across the top. So 1 times y to the 5th is y to the 5th. Y to the 8th times 1 is y to the 8th. And for now, 5 minus 8, let's just say that's y to the negative third power. Later, we're going to talk about what a negative power does. But for now, we're just going to leave it as y to the negative third. For this next one, I have to do my power of a product property here, and I have to give the power of 3 to every single base in this problem. There's 4 of them, so I have to do 3 cubed. X to the 5th to the 3rd is going to be x to the 15th. I have to do 7 cubed, and y to the 2nd to the 3rd power, you multiply to get y to the 6th. So memorizing those perfect cubes, 3 cubed is 27, 7 cubed is 343, and so this is my final answer. For this last example, what I'm going to do is when I'm multiplying polynomial or monomials, I multiply the coefficients and add the exponents. When I'm dividing, I'm going to divide my coefficients and subtract my exponents. So 20 divided by 4 is 5. Don't accidentally say that's 16, because we know what 20 divided by 4 is. It's 5, not 16. So don't accidentally subtract your coefficients. Only subtract your exponents. So 5 minus 3 is 2. 6 minus 2 is 4. So that's my final answer. So let's just do a few more examples. So I'm going to give the power of 3 into every single power first. That's how I'm going to start. There's other ways to start it, but that's the way I like to do it first. So that gives me 2 cubed. 4 times 3 is 12. 2 times 3 is 6. 3 times 3 is 9. 2 times 3 is 6. So 2 to the third power is 8. If I look at my x's, 12 minus 9 is 3. For now, let's just say if we have y to the 6 divided by y to the 6, that's pretty much going to give us 1 because it's the same number being divided. So the y's are gone completely. We'll talk more about that type of exponent property in the next video. But we're going to get 8x to the third as our final answer. Same thing for this example. Let's start by giving the power of 2 to every base in this problem. So we get 3 squared, 2 times 2 is 4, 4 times 2 is 8, and then we're going to have to multiply that by negative 4xy to the 8th. So 3 squared is 9, so I'm just going to erase that and write 9. And then I'm going to go with multiplying my coefficients. So 9 times negative 4 is negative 36. And I'm going to add my exponents. 4 plus 1 is 5. 8 plus 8 is 16. And so that is going to be my final answer. Alrighty, so for the next one, I need to give the power of 2 to the 5, to the y, and to the x, and I'm squaring a negative. If I were to multiply a negative by a negative, that's going to give me a positive, so this negative just disappears, leaving me with 5 squared y squared over x squared. And again, I know what 5 squared is. 5 squared is 25, so I'm just going to write 25 instead. Then I give the power of 2 into this fraction. 2 squared is 4. X to the 4th squared is x to the 8th. Y to the 3rd squared is y to the 6th. Now I have two fractions, so I'm going to multiply straight across the top, straight across the bottom, and that's going to give me 100 y to the 2nd, x to the 8th, over x to the 2nd, y to the 6th. And so 8 and 2 can simplify since they're like bases. 8 minus 2 is 6. 2 minus 6 is negative 4, which again, we're just going to leave negative for now since we haven't talked about the negative exponent property, but there's technically one more step we're going to have to take to simplify this, which we will see in the next video. All right, last one. So this power of 5 needs to be distributed to the negative, but raising a negative to an odd power gives me just a negative answer. So I'm going to have negative x to the 5th, y to the 10th, z to the 15th rather, 5 times 3. Then 2 times 4 is x to the 8th, y to the 2nd, z to the 2nd. And so the negative and the negative are going to actually make a positive. Two negatives make a positive. And then x to the 5th and x to the 8th are going to make x to the 13th. Y to the 10th and y to the 2nd are going to make y to the 12th. Z to the 15th and z to the 2nd are going to make z to the 17th.